Up till now, we have been discussing how Stuxnet propagates using Windows vulnerabilities. So up till now, Stuxnet has been regular malware. But now we're going into the details of what Stuxnet did exactly to the PLCs, to attack the PLCs and ensure that the PLC would be used to destroy the centrifuges. So Stuxnet would infect, as expected, step 7 project files. And to do that, it would call export2, that would have been called from its main function export16. And export2 would hijack the Siemens process, this S7 process, and would hook specific API calls, and Stuxnet would take them over. The ones that were modified would be this create file A, that will be redirected to create file A hook, where you have, when you load an S7P project, then Stuxnet would be called first, and then the regular operation will continue. The same would happen with the MCP files through this STG open storage. Instead of that, the function call would be redirected to STG open storage hook, and that would call that specific function export from Stuxnet that would record the path and then infect the project inside where the MCP file will be located. So this would infect MCP files. This would infect the S7 project files. So export 14 will be the main routine for infecting the project files, and those with special extensions, the temp, S7P, and MCP would receive special processing when they were about to be opened by those function calls. And let's see an example of one, the S7P one. So S7 project would be something like this. We saw in the lecture about ladder logic or function block diagrams. So some control logic will look like this, right? This is what you have as part of your control logic. So Stuxnet would infect a project only if some conditions were present. The first one would be the project is not too old, to make sure it doesn't infect projects that will never be executed, that it has a valid MCP file connected to it, and also it's not an example project. To infect the project file, it would do a few steps. One would be to write a few files. Those three, this MDX file, there will be an encrypted copy of the main DLL. This DB file will be the Stuxnet data file copy, and a third one would be an updated version of the Stuxnet configuration data block. After the files were created, then Stuxnet would scan this folder for subfolders and drop the DLL, the infected DLL, the Stuxnet DLL, in each one of these directories. And as a third step, it would modify a step 7 data file located in this directory, and would modify it as well. So when the infected project would open using the Siemens Semantic Manager, then this modified data file would trigger a search for that DLL we just mentioned from before in those directories, S7bin, system, Windows directory, system directory, and subfolders from before. And if that DLL file wasn't found, if that found, it will be executed. But it wasn't found, then a malicious DLL will be loaded and executed by the manager, and in a way that would add as a preloading DLL. So in a way it would decrypt. Remember, there was an encrypted copy of Stuxnet. It would decrypt and load that DLL here from before. And this is very similar to DLL preloading. So whenever you would open a project file for step 7, then this malicious DLL will be loaded, and that actually would load Stuxnet itself. And very similar process, we won't go through it for the MCP files for WinCC software. Now, let's discuss about how Stuxnet was interfering and intercepting the communication between the Windows machine and the PLC. So export 17 of the main Stuxnet DLL would be dropped, would drop actual resource 208, and that will be malicious replacement for Siemens Semantics S7 OTBXDX.dll. This file handles the PLC block exchange between the computer and the PLC. So here in the figure on the bottom of the slide, you have the PC, Windows machine, that runs the step 7 control software, and this communication between the PC and the PLC would happen through this DLL file. So you would call a function of the DLL to communicate to the PLC. So if you are to, what Stuxnet did, to replace the DLL with your own DLL, then you will be able to monitor all the PLC blocks written to and read from the PLC. You were able to infect that PLC by inserting your own blocks and replacing existing blocks, and you would also mask the fact that the PLC is infected. So whenever you read back from the PLC, you can see your special code and remove it before it's being displayed to the user. So this is an example of an actual Stuxnet block called named FC1873. So if you open it in Step 7 software, you would see the exact code of the exact PLC code of Stuxnet. So this file I mentioned before is called for communication to the PLC. So you have your code, Windows machine running Step 7, the PLC. So whenever you want to read PLC code, you would call the DLL and you would call this, for example, S7 block read to read from the PLC and see it at the software. So Stuxnet renamed the previous one it changed the letter D to S, and it would replace the original one with its own version that would contain all the function, all the exports the previous DLL had. It had 109 exports. It would contain all of them, of course. It would just forward 93 of them and intercept 16. So if that's something that's not intercepted, it will just be forwarded to the previous one to be executed regularly. But if it was one of the special 16, and these ones were the ones that would read, write, and enumerate code blocks, it would modify them, would modify the data sent and returned from the PLC without the operator knowing. And it would also hide malicious PLC code. So this, for example, this block read here would be intercepted, and the Stuxnet would run special code before it redirects to the regular read to be executed to do the final thing the code would have done. The infection process. So Stuxnet would infect the PLC whenever you have this function call that would write a PLC block to the PLC. It would infect the PLC with different code depending on the characteristics of the target system. So it would look for the type of the centrifuges and also the number of the centrifuges connected to the communication modules before it decided to infect and how to infect that PLC. So Stuxnet contained 3 infection sequences. 2 of them are functionally equivalent, and they were targeting different brands of centrifuges. The third one appeared to be disabled and was not used in the samples that were identified in the wild. So we'll discuss those 2, A and B. This infection routine would run every 15 minutes, and when it found the PLC, then it checked through that, again, intercepted the API, if that PLC was a very specific PLC type, this 6ES73152. If that was the case, Stuxnet would check 3 things. One, it would do a check on the SDB blocks, we'll see that in the next slide, to see whether the PLC should be infected, whether it matched a unique configuration Stuxnet was looking for. And then if that was the case, then it would intercept the network communication between the communication module and the PLC and replace it with its own malicious block sequence. And the third step would be to infect the main entry of the PLC program, so malicious code will be executed when the PLC program would start it. So let's see each one of these 3 things separately. First, with the SDB blocks check. This key step would see whether this SDB stands for System Data Block, and all this block will be enumerated and parsed. And what Stuxnet would do, it would try to find a block with this specific offset equal to that very specific value. This value indicates that the system uses a Profibus communication processor of this type. So you see now we're getting into detail on how Stuxnet was very targeted on a very specific configuration. So it was looking for a Profibus communication processor module of this type, and only if it found that, it would proceed to second check, and that would be for specific values, these 2, 7050 and 9500. So the check would pass only if the total number of values found would be equal or greater than 33. So it was looking for specific Profibus IDs, and these IDs would be one, a frequency converter manufactured by a specific company in Tehran, or another frequency converter manufactured in Finland. Stuxnet, through reconnaissance, knew that the specific plant it was targeting had those different frequency converter drives, so it was looking whether these drives were present before doing the final infection. Not only the types, but also enumerating them, and if more of them were of this brand, it would execute a different routine compared to if more of them were of the other kind, because the physical properties of the centrifuges will be a bit different. If it was manufactured by that manufacturer, it would need a different sequence to be damaged compared to the other one that would need a different frequency of a different sequence of changing frequencies to damage the centrifuge. So to conclude the check, Stuxnet was looking at whether the PLC would communicate to at least 33 converter drives at one of the two manufacturers, and if more manufacturer A was present, then sequence A would be chosen. If manufacturer B was present, then sequence B would be chosen. Second key step in Stuxnet infection process would be to replace the receive part of the communication module. So this DP receive is a standard function block used to receive packets from Profibus. So Stuxnet would replace the original block by its own block, and in this way would intercept traffic going to the PLC from the communication module. So every time a packet was received, Stuxnet would see the packet first, do some kind of monitoring, and then pass it to the original function before it does post-processing on the packet data. So that will be the second key step to intercept the traffic from the communication module to the PLC. And the third key step would be to infect the beginning of the PLC code, and that was simple code prepending. So that was a clean code, and that will be Stuxnet infected code here on the screen. So you see, it will just add code in the beginning of the block, and to do that, it will just increase the size, write malicious code in the beginning, and then insert the previous original code in the rest of the file. And if we look at the OB1 is where it starts execution. So it will start with this following instruction that actually execute part of Stuxnet. And it was also infecting OB35 that acted more like a watchdog to ensure that the PLC is working properly. And it was also infected that with different instructions, different function block that would start with those instructions shown on the screen. So these were the three key steps Stuxnet took in order to infect the PLC.